Hey guys, thanks for coming out this morning. I'm Rushi, co-founder of Movement Labs. We're building the first Move VM on Ethereum. My background is engineering. I started my career in United Health Group. I was a software engineer in the healthcare insurance industry and had a background in distributed systems and cybersecurity. I got in crypto around 2.5 years ago on the engineering side and really fell in love with smart contract security and high throughput blockchains. I was using Ethereum back in the day. It was getting really congested. The gas fees were too high. I was getting hacked like every week. So the question was, how could we scale Ethereum without needing to leave Ethereum? August of 2022, I went to Aptos, built one of the first applications in Aptos, and so did my co-founder, and really fell in love with the Move language, which I'll get more into later. So I'll start with the agenda. We'll start off with glossary in terms, context, go through problem solution, and then kind of the architecture and where we're headed. So first, M1 is our decentralized sequence network. We inherit consensus from the Sonoma consensus mechanism. We're really M2, the first move layer 2 on Ethereum. And a VM is essentially a virtual machine that executes smart contracts. You can think of it like an operating system in Web 2, where you're building websites and other applications for your for your computer. VM is that for a blockchain. And the EVM is the Ethereum virtual machine, obviously. Movement SDK is a software kit to execute smart contracts. The Move VM, which I'll get more into later, started from the DM project from the Facebook days. And Fractal is our EVM interpreter that enables Solidity code to launch fully on the Move VM. So what's the context? To date, there's been over $8 billion lost in smart contract hacks. Last year, there's $4.5 billion lost, mainly through smart contract vectors like re-entity, integer overflows, and whatnot. Here's kind of a breakdown of attacks we're seeing. 17% private keys, 6% access controls. You can recognize some of these big attacks. If you look at Peck Shield, which is like the most infamous Twitter account for security, it's like every week there's a new attack for $50 million, $60 million. So the current state of smart contracts are pretty broken, such that if you're writing Solidity code, it's around 95% of attacks come from EVM attacks. And if you are EVM protocol, you're probably exposed to 92% of any likelihood of attack at any given point. So for those that aren't familiar, Move was designed from the DM program. It was back in the Facebook days where Facebook wanted to build a blockchain to power the billion users on Facebook to a stablecoin on chain. We looked at the EVM and SVM and decided that it wasn't secure enough. The thesis was if you're going to have like customer funds of like 14-year-olds or 70-year-old grandmas, you probably want to make sure it's not getting hacked every day. So the DM project was introduced, which is a new VM. It essentially has the Move prover built in that supports formal verification, so you have security at runtime, which solves a lot of the issues that we're seeing in the EVM. Here's some numbers. So obviously, DM Libra introduced the Move VM. There's around a market cap of $4.5 billion. I think it's like $9 billion. Obviously, it's still very nascent. I like to say it's like the first year of Solana, where if you're around for the first year of Solana, it's a very difficult experience. You had a crappy wallet. There's pretty much no developers. There was Rust, which was a new programming language at the time. Move is in a similar state. We're still very nascent. The community is growing. And our thesis is to bring Move to the broader Ethereum and EVM communities. So bridging Move and EVM is our thesis. So can we enable safer smart contracts within Ethereum? And the answer is yes. Can we bring Move to Ethereum? Yes. Our solution is a Move-based rollup on Ethereum. So quick primer on rollups. I think most of you guys probably know this. I'll go quickly through this. Optimistic rollups use fraud proofs, unless you're Optimism. Now they're putting it in. But generally, optimistic rollups always have fraud proofs. ZK rollups use validity proofs. The things that are computation expensive. The benefits is high throughput, low gas fees on Ethereum. So what is M2? It's a ZK rollup on Ethereum. We use ZK proofs for validity to prove on Ethereum settlement layer. We're starting off with ZK fraud proofs, given that a ZK Move VM is very computation expensive, but eventually transitioning to a full end-to-end bytecode compatible ZK Move VM. It's fully EVM compatible, so if you're writing a Solidity smart contract, it runs end-to-end with EVM bytecode. A little bit of the architecture, so you can recognize the Movement SDK, which enables smart contracts to be deployed. You have a data availability service, prover marketplaces. I'll get more into the verifier contracts as well. Here's a little bit of the SDK where you obviously have the move side of things, which is pretty straightforward. You write move code, whether it's apt.us or sweetmove, it compiles down to the same VM because of the same bytecode. But what's really interesting here is that we built the EVM interpreter on top of the virtual machine. Our general thesis is that move is very secure, but it's very nascent developer group, as with any new ecosystem. So the question is, how do we bring EVM developers and Solidity developers using move without them knowing it, such that move becomes a feature, not a requirement? So with the SDK, we enable end-to-end bytecode compatibility with Solidity codes. So it's MetaMask compatible with Ethereum JSON RPC. It works, talks, and looks like an EVM, but runs the move EVM under the hood. So we call it like a parallelized move EVM. Here's a little bit of how the translation process occurs. You take a Solidity script, you parse it to an abstract syntax tree. Essentially, you take the 142-ish Solidity opcodes, map it to the 54-ish move opcodes, and run a many-to-one pair. It maps it to an intermediary language called Yule, which is essentially assembly-like language that can take the opcode from Solidity opcodes and map it to move opcodes. One thing to note at the current implementation, the move side of things takes static dispatch, which turns off re-entry automatically, and the EVM side still has dynamic dispatch. We're working on making the EVM side of things more secure, but we advertise that if you want to write the most secure code and not get wrecked and have the best performance, you write move. If you're going to be stubborn, we'll support Solidity, the back end. So the end thesis is move is still more secure, but we want to provide backwards compatibility for legacy code. So if you want to fork Aave, probably best to use Solidity, but if you want to build a new consumer app that's not going to get hacked, let's write move. Let's go with this. I think the biggest issue with L2s today is a centralized sequencer. If you look at inscriptions, basically every L2, like Arbitrum, ZK Sync, et cetera, all went down after 100 TPS, which means that if we ever actually have users on chain or a consumer app, it can't scale to more than like 100 TPS. So with that, we built a fully decentralized sequencer that not only sequences our layer 2 as well as other layer 2s. A allows for preventing uptime issues. So even if one node goes down, there'll be plenty of more other nodes sequence the network. We're working a lot of censorship in security. So everyone argues that censorship is bad, or if I could tell you censorship could actually be good, such that if there's a fraudulent transaction coming in, imagine if North Korea is trying to hack your system, you can actually use the sequencer itself to silence transactions. If there's a, let's say, a re-entry attack coming, you can move back to the linked list and chop it up, and essentially bring censorship as a service. The main chain will be credibly neutral and won't promote this, but the thing is, we'll have a network of blockchains. So let's say your order book rollup, you want to KYC it, you don't want to get hacked. You can essentially turn on the censorship, and you can silence a lot of the issues that we're seeing in security. We use a Snowman consensus, which is actually derived from the Avalanche ecosystem. It's a leaderless BFT consensus mechanism. It's similar to Avalanche's, but without the total ordering. It doesn't require the staking of AVAX, so no, we are not an Avalanche project. We're simply just using the consensus. You can think of like a Veils use Substrate, and plenty of groups use Tendermint as well. It's a proof of stake network for M1. It's still resistant. The validators actually stake the native token to participate in sequencing. The typical with other L2s is no business models. Most L2 tokens are meme coins, governance tokens. But with our token, you validators actually have to stake the move token to participate in sequencing for layer 2, as well as other layer 2s. We're announcing some pretty big partnerships with your favorite protocols, all launching with our stack. It's actually complementary to other rollup stacks, so you can use the OP stack, you use the Arbitrum over stack, and use the VM on top of it. So we're actually just bringing parallelization and high throughput blockchains to every ecosystem. A little bit how the sequencer network works. You have the full nodes connected with light clients, and then provers to make it connect to the SDK itself. So a little bit of the marketplace. I think today's marketplace, ZK proven networks are pretty centralized, and the fees are pretty high, such that it's pretty, like ZK EVMs are usually pretty costly. We're working on building essentially a Move ZK marketplace in-house, where the provers can generate proofs. Right now we're using Bonsai just for testnet, and working with Rushi on this front, and eventually Succinct as well. But we're looking at Plonky 2 ZK proven marketplaces, so we can actually outsource the proving to a bunch of nodes with a network. They generate ZK Move proofs, and they can prove the VM. The intermediary step to launch testnet and kind of go to market is ZK fraud proofs, where you have challenge periods with optimistic rollup, but you also have ZK proofs that kind of still embedded. This layer. So the intermediary goal is to launch M2 I touched on as optimistic rollup. The biggest issue with next-gen VMs is that if you want to do a ZK Move VM or ZK SVM, even if it's 1 cent to approve every transaction, that's still very high because on Ethereum, our transaction fees will be anywhere from 2 to 3 cents. So if we're approving a transaction for every cent, it's very difficult, and that's best case scenario. Current implementations are like 5 to 10 cents per transaction, which makes a next-gen ZK VM pretty difficult. But we're working with a few groups to try and bring the cost down. But in the short term, ZK fraud proofs are great. I believe Layer N started this with the receiver team, and now we're also bringing it to Ethereum with Move. And kind of where we're headed next is we believe that formal verification security should be a standard. We're kind of sick and tired of the $4.5 billion lost every year in hacker attacks. If you want your mom to ever use crypto, they probably don't want to get hacked for $4.5 billion. They want to deploy ETH on chain, just let it sit in a yield farm and have safety in it. We're working with a lot of insurance funds to provide insurance on chain. So what gets me excited about security is that in the past, because smart contract risk was so high, it was difficult for yield farmers or even liquid funds to deploy ETH on chain and get insurance to back the collateral. What if there's a world where, because smart contract risk is so minimized, you can generate actual insurance premiums that make sense and provide with like an eigen insurance or a third-party Nexio provider and have the insurance backup as collateral. So if you deploy ETH into a yield farm, because there's no smart contract risk, basically, your insurance premium is much lower. So it actually incentivizes retail capital to come in. So in the short term, I think DeFi is a really interesting use case for us where we could provide essentially the most secure way to deploy ETH on chain into your favorite apps and working with some of the biggest DeFi apps that you know. Yeah, that's it. Thank you, guys.